JMP has a very powerful scripting language, but you don't have to be a programmer to use the script editor. You can use the editor as a command line calculator, and by doing that it's going to give you access to JMP's very large library of mathematical and statistical functions. Now the chances are, if you've never written JSL, you've never even opened the script editor. So I'm going to first of all show you how to open it and then how to configure it so you can easily use it as a calculator. Once I've done that, I can show you some simple calculations just to give a feel for how to use the editor for doing calculations. But then I'll take you into what I think is a very interesting example where we're doing calculations based on non-conformance. To launch the editor, I select the second icon on the toolbar. Within the editor, I can just type simple arithmetic statements. If I click the Run button, then the answer gets displayed in the log. So we want to see the log output. I can right click and I can show an embedded log, which shows the log in the lower portion of the script window. So now when I click Run, I see the answer. The answer is 8, and it just shows the calculation again. This calculation could involve mathematical functions, so log 100 will give me the results of a natural logarithm. And if I just hover over, well, first of all, notice that the log is in blue. That's a way of JMP telling you that it recognizes log as the name of a function. And if I hover over there, I'll get a tooltip appearing, and also at the bottom of the window you'll see a description of the function. So notice there's a second argument. I can actually put (10) and I get then logarithms to base 10. Another example of a function would be to use a square root. Now these calculations don't have to occupy a single line. So here I have 2 lines, and to delimit the lines I'm using a semicolon. And you can see here I'm using the pi function to give me the value of pi, and I'm calculating the area of a circle. When I click Run, it always shows the result of the very last calculation in the script. If I explicitly want to show results, I can type this. Okay. But we're not going to really use JMP to calculate areas of circles. So now let's look at calculations more specific to JMP related data. For these data, I could ask the question, what proportion is less than 70? Imagine 70 is a lower specification limit, and I want to calculate the level of non-conformance. Then in my example, what I have is I have 14 rows that have been selected. That shows up here. 14 rows are selected out of a total of 88. So I have a non-conformance of 15.9%. If I want to show this as a percentage, just multiply by 100, and maybe I can just round this to 2 decimal places, 15.91%. Okay, so I have a non-conformance of almost 16% here. That's based on the data. That's based on a sample of 88 data points. What if I model this distribution as a normal distribution? If I assume the process is normally distributed, then what proportion would be less than 70? Let's do that calculation. So I'm going to say my lowest specification is 70. I've got a mean for this process of 72.86, and the standard deviation is 3.54. And I can use the normal distribution function that's available in JMP to do a calculation based on the specification limit for these parameters. And based on this, and if I just want to run these lines of code, I can just highlight them. Based on that, I have almost 21%. Maybe let's do this. Again, just round P to be 2 decimal places. So we have literally 20.96% out of non-conformance based on that spec limit. Now, in fairness, this calculation we could have just done interactively in JMP. I could have come to here and do a process capability to give me the same result. What you couldn't do so easily interactively in JMP is to invert this problem. So what do I mean by that? Let's ask a different question. Let's say we have flexibility in the choice of our specification limit. Maybe we're developing a new product or process, and this is under negotiation, this spec limit. And we want to have a non-conformance less than 10%. So what we can do is the following. I'm going to keep these values here, but let's just take the mean and standard deviation again. I'm just going to copy those. And I'm going to say that I want my proportion to be 10%. So as a fraction, 0.1. And instead of using a normal distribution, I'm going to use the inverse of a normal distribution, which is a normal quantile. So whereas a normal distribution takes a specification limit and converts it to a probability, this will take a probability and it's going to convert it to a specification limit based on the parameters for the normal distribution, the mean and the standard deviation. So now let's see what the new specification limit is in order to achieve non-conformance no more than 10%. And the value is 68.3. So if we reduce the specification limit from 70 to 68.3, the level of non-conformance goes down from about 20% to 10%. I hope you found this video helpful, and if you did, then please give it a like and think about subscribing so you can easily find future videos. All the best and bye for now.